problem 8.2.11. So here the question is to compute L1, L2, L3. So L0 is already constant equal to 1. L1, L2, L3 are the orthogonal polynomials over this interval with this weight. Okay, so now we can again use the recursive formula instead. So recursive formula tells us to do this. So here is L1 should be x minus this. Again, I supposed to have the L0, L0W, but that is just a 1, so I can ignore that. So that's why we have, so this is the x, so going here, and then this integral here is going to be x times the L0, which is 1, then times the w, so w is this part. So you need to take an integral of this thing, now times the L0, which is 1, and divided by 1, but I ignore it. Now here, this one, I take the integral of that just becomes 1. And then remember to find the integral of this one, you need to do the integration by parts. Okay, so you need to do integration by parts for once, then we'll get this equals to 1. So that's giving us the x minus 1 for L1. Now for the later ones, for example, for k equals to 2, we need to compute the B2 and C2. For the B2, the formula is this. Okay, and then you just need to plug in x is just x, L1 is this one here, and the w, remember, that's just e to the negative x. So you plug in everything, you get this one here. So now you expand it, you get this. Okay, so now the question is, there are lots of terms like this times the ex, e to negative x. So I will have a general formula for that. So the general formula for that, you can actually, if you haven't seen this before, you just search for the gamma function. So for gamma function, this is called a gamma function. So when you, sorry, the integral of this is called a gamma function. So for every integer k, you actually can plug in other numbers. It doesn't have to be an integer. It could be any real number, positive real number here. But for the positive integers, this one is shown to be k factorial. Okay? Once you have the x here, you can do this, and it should be k factorial. So to find this, you can use induction. For simplicity, you can just use induction and some integration by parts. You can get by this. So now this tells us that once you see x cubed and x to the e to the negative x, take the integral, that's just a 3 factorial. So that's why the numerator just becomes 3 factorial minus 2 times 2 factorial plus 1 factorial, which is just 1. Denominator is similar, then you get a B2, which is just 3. So similarly, you can do this for the C2, and the C2 has this formula here based on the recursive formula. And again, the numerator just becomes this. And you can see that you're going to have x squared minus x, and that will be 2 factorial minus 1 factorial. And denominator is just 1, so that's why here you just got C2 equals to 1. Now you can apply the recursive formula. The L2 is just the x minus the B2, which is this, times L1 minus C2, which is, sorry, it should be 1 here. Don't have this. Okay, so I have minus 1. Then we'll get this. That's what will be the L2. So based on L2, you can compute B3 and C3, and then you get the L3, okay, which is eventually equal to this.